Hey, welcome back to Rithmetic with Ron. Today we're going to talk about scientific notation, and I'm going to show you a quick and easy way to change standard numbers, which is how we write day to day, into the shorthand called scientific notation. Okay? Hope you enjoyed today's video.
Let's take an example here of a big number and a small number. We're going to start with these numbers in the standard form, which is how we typically write numbers, and we're going to convert it into scientific notation. Now, what I've done for each of these big and small numbers is I've already written the answer, but I'm going to show you how to quickly figure out how to convert from standard into scientific. Since we write this way, we usually start with this, and then we can write it, think of scientific as like a shorthand. So starting with 45,000, what I'm going to do is find out in this number, where is the decimal, okay? I'm going to put the decimal down and I'm going to move it so that now my starting coefficient in scientific notation is a number between 1 and 10, okay? Since 4.5 is between 1 and 10, I want to move the decimal so that I get 4.5. And I'm going to count the digits, 1, 2, 3, 4. Not digits, the place values. How many spaces did I move that decimal? I moved it 4 spaces, which is why I have a 4 on the as an exponent to the number 10. The other thing we want to know is what direction we move affects whether this exponent is positive or negative. So in the number 45,000, 4 is in the highest or the largest place value. It's in the 10,000s place. So if your decimal is moving towards the highest place value, then your number is going to be positive. Your exponent will be positive. Let's see what happens down here with a very small number. 3 is actually in the smallest place value. And what happens when I move the decimal to make my leading coefficient between 1 and 10? 3 is a good number, okay? So 1, 2, 3, 4, 5. The number 5 is going to be my exponent, because that's how many place values I moved the decimal. But because the decimal is moving in the direction of the smallest place value, then it's going to be a negative. And you can think to yourself in these examples, -5 is smaller than 4. 4 is bigger. The decimal was moving towards the biggest place value. -5 is smaller, and here the decimal was moving towards the smallest place value. This method works in terms of looking at the direction that the decimal is moving towards the small place value, negative number, towards the big place value, positive number. That works if you are going from the standard form and converting it to the scientific form, which I think makes the most sense because this is how we typically write numbers, and then we can convert it to scientific or shorthand to make calculations easier. So 2 more quick examples just to reinforce that point. Let's say that in standard form I have the number 350. I want to convert it to scientific. I'm going to start by realizing that my coefficient in scientific, okay, the coefficient is the number out front. It needs to be between 1 and 10. How can I put a decimal in here to get between 1 and 10? 3.5. So I'm going to start recognizing my decimal is out here. If this is the number 350, and I'm going to go 2, and that's going to get me my 3.5. So 2 places, okay? So 2 is my exponent because that's how many spaces I moved the decimal. That gives me my leading coefficient of a number between 1 and 10. And then because I moved the decimal towards the largest place value, I'm thinking largest, I'm thinking big. So 2 is a positive number that's bigger than if we were to go in the other direction and have a negative number. How about 0.005? Okay, well, I'd like my leading coefficient to be something in between 1 and 10, so 5 is a good candidate. Let's move the decimal 1, 2, 3 places is going to get me a 5, okay, because the number 5 has the decimal point sitting just to its right. So 3 spaces gives me a 5. I'm going to write the number 3, but because I moved the decimal in the direction of the smallest place value, I'm thinking small, which means a negative number is small. So from standard, if you move the decimal to the right, you have a negative exponent. If you move the decimal to the left, you have a positive exponent, and the actual number is the number of places that you had to move the decimal to go from your standard form to your scientific form with your coefficient.
So today we saw a really quick and easy way to change standard notation, which is how we write, into the shorthand scientific notation, which is really useful for doing math on big numbers and small numbers. Go ahead and hit subscribe, send me any comments, and we'll see you next time.